that we learned today. All right, so for today's lecture, okay, we are going to learn about chapter 2, vector value functions. Okay, guys. So today we will focus on subtopic 2.1 and 2.2. Okay, subtopic 2.1 and 2.2. So your quiz this week starting on Friday at 9 a.m. Okay, quiz 2. The topic that covered this week for quiz 2 is topic 2.1 and 2.2. Okay, we have 4 questions, multiple choice questions. So as usual, we open the quiz for 24 hours in column. So you can choose at what time that your internet connection is the most stable. Okay, so you can do it at night, in the early morning, it's up to you. We open the quiz from 9 a.m. on Friday. Okay, until 9 a.m. on Saturday. So you have 24 hours to do your quiz, okay? And again, happy Deepavali for all my students who celebrate Deepavali. Okay, so Maruku ada lagi ke? Tak ada respon pun, you all dengar ke tak ni?
Dengar, madam.
Dengar. Biasa bukan ke kalau Deepavali you all Indians akan buat Maruku sendiri kan? Because I have one best friend now. My best friend is Indian girl. Every year masa Deepavali, she will give me the Maruku, homemade punya Maruku, sedap sangat. So sekarang dah PKP, dah jarang jumpa lah, dah susah nak jumpa dia dekat KL, saya dekat Kuantan, so I miss her a lot lah. Okay, right, sedikit iklan pula. So we get back to our lecture today, vector value functions. I believe some of you did not watch yet all the videos, but that's okay. Okay guys, I will cover all subtopics today. I'll give you some examples. So vector value functions in general, the notation, all right, we will have a vector of R. Or before that, paper, okay. In general, we have vector of RT. Okay, so when we denote the vector, you should put this tilde, ni, symbol tilde for vector. Okay, so we will have RT equals to the x component function for I direction plus ytj, also with tilde, ini tilde, and then plus ztk, right? K pun ada tilde. So we have 3 components, right? I, j, and k. Or sometimes we also can write vector as this, equals to a sharp bracket or acute bracket. Sharp bracket equals to xt, yt, and zt. Okay, so it's up to you. Either you want to use ijk or you want to use this bracket, sharp bracket for a vector. Okay, this is the notations lah. All right, and we already learned about vectors indirectly in chapter 1. Okay, in chapter 1 in the equations of lines and planes. Kalau you ingat lagi kan, kita ada belajar vector dalam chapter 1 lah. Okay, so now for subtopic 2.1, first we are going to learn about domain. Okay, domain. What is domain, guys? Anyone? What is domain?
From left to right.
Sorry?
From left to right, x-axis.
From left to right. Okay. Acceptable. All right. Domain is actually all possible values of t that fulfill the functions. Okay. All possible values of t that fulfill the functions. Okay, kalau misal kata there are no restriction, then t can be from negative infinity up to infinity. Okay, I'll give you one simple example. Example 1. Find the domain of the vector function find the domain of the vector function. Let's say your rt, the vector of rt equals to 3t sine 2t and then exponent 2t. Okay, like this. So now what should we do here is we need to identify the domain for each component. Okay, for each component I, J and K. So kita kena cari satu-satu lah one by one. So solution. First of all, we have domain of 3t. Domain of 3t. Okay guys, 3t is categorized in what group? What type of function 3t? 3t is categorized in polynomial. Okay, polynomial. So all functions of polynomial, okay, the domain for 3t should be this.
Negative infinity.
Yes, negative infinity up to infinity. So there are two ways to denote the domain. First, we have set in terms of set, S-E-T, set, t such that t element of real number, like this. Or, okay, in bracket, we have open or close bracket. We have from negative infinity until infinity. Okay guys, yang curve ni, this is actually kalau curve to curve bracket ni, this is open bracket. Open bracket means not include, not include. Kalau macam ni, square bracket ni, close bracket nama dia, means that include that number. Okay, include the number. So, okay, in my class this morning, one student asked me, Madam, why negative infinity we have open bracket instead of closed bracket? Because negative infinity up to infinity, infinity is a very large number, so we don't know the exact values of that infinity. So that's why we need to put it as open, okay, open bracket. Because in number line, it's this way, from negative infinity up to infinity. So we don't know the exact values here. That's why we put it as open bracket. Okay. Understand, guys?
Yeah.
So next we have domain of sine 2t. Okay, did you have your calculator with you now? Okay, let's say, okay, sine 2t is trigonometric function, trigonometric function. You can use plug in any values of t inside trigo. You still get answer. Okay. For example, let's say sine negative 100. You still can get the answer. However, okay, right now, if I ask you now, okay, use your calculator. Click pula. Key in ln 0. Can you get the number from your calculator? The answer?
No.
No. Okay, which means that
Infinity.
no, I mean ln 0. Ln tekan je, ln 0. You will get math error, right?
Yes.
Yeah.
Let's say ln t. If I ask you to key in ln 0, you will get math error. in your calculator, undefined. Okay, which means that t cannot be equals to 0 for long. Okay, however, for sine 2t, we can plug in any values here. All values of t are valid. Okay, for trigonometric function. No restriction at all. But for long, kalau t equals to 0, tak boleh. Okay, that's the restriction. Itu maksud saya restriction tu. Maksudnya kalau kita masukkan nilai t equals to 0, kalau long dia jadi tak valid. So itu restriction untuk domain bagi long. Tapi dalam case sine, for the case of trigonometric function, all values of t are valid. So we can say that again, the domain of sine 2t must be from negative infinity up to infinity. There are no restriction at all. Okay? So next, the last function, we have domain of exponent 2t. Okay, so exponent 2t, again, same concept. You can plug in any values of t dalam exponential. Kalau you tekan calculator, exponential, let's say you have exponential negative 0. Still valid? Yes, valid, ada nilai. Kalau you tekan exponential 999, still valid, ada nilai. Okay, so t for exponential function, again, no restriction at all. So dia tak ada restriction langsung. Okay, so again, since there are no restriction, so the domain of exponential function, exponent 2t ni, domain dia can be from negative infinity up to infinity. So question number 1 is very simple lah. Alright, the domain of RT, you should combine all of this. So negative infinity, intersect negative infinity, up to infinity, and so on. So, okay, so yes, of course, the domain of RT should be from negative infinity up to infinity. Sebab dia sama je dalam dua case ni. So that's it. That's the answer for the first case. Very simple. Okay. Example number 2. Let's say I change the equation. Again, find the domain of the vector function. Let's say we have RT. Ni example 2. RT equals to, let's say we have a fraction t minus 3. Okay, and then square of t plus 5. And then let's say we have 10, a constant here. So now, solution, we need to identify the domain for each component. So the first component, guys, for the domain of 1 over t minus 3. Okay, now I want you to use your calculator. Can you find 1 over 0? Use your calculator. 1 over 0 equals to what?
Undefined.
Undefined, right? So undefined. Or math error, dia tak keluar jawapan, undefined. So yes, if you have 1 over t, t as the denominator, fraction, t to pembawah, t cannot be equals to 0. Okay? But t can be negative, t also can be positive, except 0. Okay, kecuali 0. So what we can do here for the domain of 1 over t minus 3, okay guys, dalam case kita ni, t minus 3 cannot be equals to 0, therefore t cannot be equals to 3. Alright? In other way, we can write the domain for 1 over t minus 3 as this. Set t such that t element of real number. Okay, ni element of real number. Real number, which means that t can be from negative infinity up to infinity, but, okay, comma, but t cannot be equals to 3, like this. Okay, that's the domain for 1 over t minus 3. Or, in bracket, you can have this, open the bracket, from negative infinity up to 3, union of, open the bracket, 3 until infinity. Okay, so you can write either this method or this method. Okay, so you kalau you selesa guna set, you guna set lah. Kalau you selesa guna bracket, then you can use bracket. Okay, next, domain of square root t plus 5. Domain of square root t plus 5. All right. So, like what I mentioned in chapter 1, if you have square root sign, means that the value inside this square root, okay, the value inside this square root must be greater or equals to 0, right? You cannot have negative inside the square root. You cannot have negative 2. For example, cannot this, okay, because it becomes a complex number, imaginary number. Dia tak wujud in real. It's become imaginary. So we cannot have negative inside the bracket. So how to do this? T plus 5 by who or by group, it must be greater or equals to 0. Okay, therefore T must be greater or equals to negative 5. Okay, apa maksud equal sign ni? Equal sign?
Include.
Yes, include. Okay, means that T included negative 5. So in other way, we can write in bracket, the domain is equals to what? I should use
Negative 5, 3.
Okay, negative 5 until infinity, right? For this, for the domain of square root T plus 5 ni. So I should use close bracket because include. Okay, ni close bracket, negative 5 until infinity baru open bracket. Okay, use this close bracket ni, which means that include negative 5 because we have equal sign. Okay, so next domain of tadi kita yang ni dah settle, yang ni this one also settle. Now this one 10. So domain of 10. So domain of 10 is equals to, okay guys, since this is a constant, so you can use any t lah, dia tak ada effect pada t, so t is from negative infinity up to infinity, dia tetap 10. So doesn't matter, right? So that's why the domain of 10 is negative infinity until infinity. This is applicable for all constants. Okay, kalau constants je, dia mesti negative infinity up to infinity. Alright, so now we have to combine all of this. 1, 2, 3, domain. So negative infinity, 3 union, 3 until infinity, intersect dengan negative infinity up to infinity, and then intersect and from negative infinity up to infinity. Okay, how to do this? Okay, I'll teach you step by step. The first one we have from, okay, domain, this one, negative infinity, 3 union, 3 infinity. Okay, must be like this. Okay, let's say I have a number line here. So here is negative infinity up to infinity. All right, and then we have this. Okay, so the second one is from negative 5 up to infinity. And then the third one, we have negative infinity up to infinity. Okay, so now for the first line, we have, okay, let's say here negative 5. And let's say here we have 3. Okay, so the number line of the first domain should be like this. From 3 until here. Okay, this means not include. This symbol means not include 3. Not include 3. Okay, and then negative 5 until infinity. So negative 5, we have from here, kita hitamkan dia, we bold the circle from negative 5 until infinity. Okay, this means include. Include. Kalau bulat penuh ni dia include. Kalau dia bulat kosong dalam tu dia not include. And next from negative infinity up to infinity, of course we have this. Okay, the arrow like that. So now the intersection. let's say I use blue color, the intersection is just this line, right? Just this area. Stop right there. So we stop until this. Okay, so the intersection should be, the answer is therefore, the domain of RT should be equals to domain of RT equals to, okay, we start from -5 until 3, union with 3 until infinity. That's the answer. Okay, because we take the intersection area, yang the color biru tu, the blue color. Understand, guys?
Understand.
Okay, good. Next, question number 3. Example 3. Find the domain of, let's say, RT. I give you a different equation now. Okay, let's say square root of 8 minus t. And then we have a ln. Okay, let's say ln t plus 3. And then exponential 5t. Okay, like this. So solution. Again, we need to identify the domain for each component. So domain of square root 8 minus t. 8 minus t should be, now we have square root sign. Again, as I mentioned earlier, it must be greater or equals to 0. Therefore, what you should do, we have 8 minus t must be greater or equals to 0. Therefore, negative t must be greater or equals to negative 8. Next, what happened? What happened when we change the negative sign?
Sign akan berubah.
Yes, we should change the inequality sign, right? So it becomes less than or equals to positive 8 because negative divided by negative, so it becomes positive lah. So we need to change this. Okay. Therefore, in bracket, we start from negative infinity until 8 and then close the bracket. Okay, which means include 8 because we have equality sign here. Okay, so stop. That's for the domain of square root 8 minus t. Next, domain of ln t plus 3. Okay, ln t plus 3. As I mentioned earlier, ln 0 are undefined. Ln 0, undefined. How about ln negative 1? Cuba tukar kalkulator, wujud tak ln negative 1? Ln and then letak negative 1. Ada tak nilai? Tak wujud, right? Math error. Undefined.
Not error.
Math error, tak wujud. So, which means that the values of t dalam ni, nilai dalam ni, t mestilah lebih besar daripada 0. Okay, must be greater than 0. T cannot be negative and t also cannot be 0. Dalam case square root tadi, t can be 0. Dalam nilai ni boleh jadi 0 yang atas ni. This one. T can be 0, ada equal sign because square root 0 is 0, right? So square root 0 is 0, valid. But now this is invalid. Ln 0 invalid, ln negative 1 also invalid. So that's why the value here must be greater than 0. Cannot be equals to 0. So dia tak ada equal sign. Dia lain daripada atas ni. Okay. So we will have t plus 3 must be greater than 0. Like this without the equal sign. Right. So now t plus 3 greater than 0, therefore t should be greater than negative 3. So in terms of notation, kita letak dia jadi apa? Therefore the domain should be
Open bracket negative 3 until infinity.
Open bracket.
yes, open bracket negative 3 until infinity. Okay, well done. Next, domain of apa lagi last kali ni? Exponent 5t. Okay, exponent 5t. We have exponential tadi saya cakap apa? Dia tak ada restriction kan? There are no restriction at all. So we have from negative infinity up to infinity lah. Okay, this the combination from negative infinity up to 8, intersect with negative 3 until infinity, intersect with negative infinity up to infinity. Okay guys, if you are already expert enough, then you can straight away put the answer. If you don't know what's the answer, then you can do step by steps. Okay, so we have negative infinity up to 8, and then we also have negative 3 up to infinity, and then we have negative infinity up to infinity like this. So we have this 3. Okay, so we have a number line start from negative infinity until infinity. Okay, so now the first one from negative infinity up to 8. Okay, let's see kita plot dulu. Here negative 3 and here is 8. So the first one should be from 8 like this lah. Okay, until negative infinity macam ni. And then we have negative 3, so open like this until infinity, like that. And then from negative infinity up to infinity. Okay, so the intersection domain should be this, from here until here. Okay, so this is the region. So now therefore the domain of RT should be equals to from negative 3 until 8, close bracket. So that's it. Understand guys?
Understand.
Okay, good. So
Yes,
now
doctor.
let us learn how to sketch the vector. Okay, I'll give you the easier way to sketch the vector. Okay, sekejap Pandang dulu. Alright, question number 2. Exercise 2.1. Okay, let us do question number 2A. Okay, sketch RT as 2 minus T, 3 plus T. Okay guys, first of all, this is our X and this is our Y. Okay, X and Y. So of course, we can write X equals to 2 minus T and then Y equals to 3 plus T. So from here guys, what you should do, we just can use what we already learned in chapter 1, parametric equations. Ingat lagi tak? So you can from here, from X, you can take,
Masukkan the line.
yes, you can find your T now. From X equals to 2 minus T, so T equals to 2 minus X. Okay, then so just substitute into Y. Okay, substitute in Y, we have Y equals to 3 plus 2 minus X, just substitute the T, so Y equals to 5 minus X. And then just use intersect form. Okay, just like chapter 1. Sama je. So we have Y plus X equals to 5, so Y over 5 plus X over 5 equals to 1. So then we will have this graph exists, plot exists. Okay, X and Y, so we have 5 here, we have 5 here, so this is the straight line. That's it, siap lah. Okay, in case kalau you want to know the direction, sama macam chapter 1 juga, kita tengok kan, dia increase ke decrease kan. So sama je guys, this one should be decrease lah, this one increase. So decrease X to the left and increase Y upward. So therefore we have this. Okay, that's it. In another way, kalau you nak determine the vector, since this is a straight line equations, you nak pergi chapter 1 equations of line. equations of line. This is another way. Kita kena ada P naught dengan vector kan? P naught and parallel vector. So P naught dalam kes ni adalah from this equation. What's the P naught?
0, 5.
Mana
5, 0.
pula? Bukan ni. From here, from this equation,
Oh.
equation of line. Should be from, we have 2 and 3, right? It's okay. As long as you respond, I already happy. Okay, next, V dia apa? Berdasarkan yang saya highlight kuning ni. Parallel vector dia.
-1, 1.
Yes, -1 until 1. Okay, so kalau kita plot parallel vector ni guys, from the origin, -1 to the left, okay, and then we goes up. So we have this, see, dia parallel kan, direction dia tu. So that's the concept of equation of line lah. Okay, so in order to answer this type of question, you can use parametric equations ataupun you can use the concept of equation of lines tu. Sama lah. Okay, either one. Next question, let's say we do question C. Okay, question 2C. Question 2C. We have this. Okay, RT equals to square root t and y equals to 1 minus t. So just x equals to square root t and then y equals to 1 minus t. So from here we have t equals to x squared, thus y equals to 1 minus x squared. So straight away sketch the graph. Very simple. So straight away sketch the graph. Where is the position? Upward, downward, right or left?
Downward.
Downward, and then we shift 1, right? So we have this. However, since x is square root of t, so x must be greater or equals to 0. Therefore, we don't have the negative part here. We don't have this part. Okay? So we just have the positive part of x. So right here is 1, here it's 1. That's it. And how about the orientation? How about the orientation, guys? Sekejap ya, saya punya bateri dah low sekejap . Okay, saya tak termasuk rupanya. Saya plug in tadi. Okay. What's the orientation? Upward or downward in this case? Look here. Macam chapter 1 hari tu, kalau you tengok function ni, when increase values of t, x should be increased. How about this? When we increase values of t, what happened to y? Decrease, yes. So below y decrease, it becomes downward orientation. Okay, that's it. So the same thing happened here lah. How about D? D ni bentuk apa, guys?
Circle. Ellipse.
Circle ke ellipse? Yes, ellipse. Right, the value here and here are different. Need 2, right? There are 3. So we have, this is ellipse. Okay, ellipse. How about this? Question E.
Circle.
Circle, but we have restriction here, pi over 2. Pi over 2 dari darab 2 sampai pi lah. So it should be a semicircle, right? Semicircle. Okay, now question F. Jom kita buat question F ni, dia menarik sikit. So question 2F. Okay, if you notice here, kalau dua ni saja, this is your X, this is your Y, this is your Z. Okay, if we don't have Z equals to T, then we can get a circle. However, we have T, Z equals to T. Okay, Z equals to T means this is your height, ketinggian. Okay, so guys, actually, for this type of equation, the curve should be like this. Okay, we will have this X, Y, and Z. Dia punya curve tu akan bentuk dia macam ni guys. Dia macam tu. Sampailah T naik atas lagi. Okay, I will explain why we get this type of curve. This is called as circular helix. Nama dia circular helix. Okay, bentuk helix kan? Dia circular lah. Sebab dia punya, the value here is the same. Okay, so now, okay, when T equals to 0, we have R0. R0 equals to 3 cos 0, 3 sine 0, 0. Okay, so we will have 3 cos 0. Cos 0 is 1, sine 0 is 0. So 3 times 1 is 3, 0, 0. Okay, so xy plane, maksudnya pada level no height. Okay, your height equals to 0. Ni height ni. No height. Ni height equals to 0. Okay, maksudnya pada xy plane. We have coordinate of 3, 0, 0. So this is the coordinate. Saya pakai marker, saya pakai pen biru lah. So here we have 3, 0, 0. That's the coordinate. Okay, next, let's say I increase the values of T. When T equals to pi over 2. Okay, we increase the values of T. Substitute T equals to pi over 2 into the vector function T. So pi over 2. We will have 3 cos pi over 2, 3 sine
0.
pi over 2. Yes, good. Okay, so we have cos pi over 2 is 0. Yes. Sine pi over 2?
3.
Equals to 1 kan? So 1 times 3 dapat 3 lah. Okay, good. So we have 0, 3. Sorry, belakang ni bukan 0. This is not 0. This is the values of T kan? So pi over 2 lah. Okay, guys, kalau if I ask you to change pi over 2 into decimal number, what should you get? Pi over 2 in decimal number. Dapat apa ni?
571.
Yes, 1.57. Okay, so we will have a coordinate of 0, 3 pi over 2 where pi over 2 is 1.57. So logically, guys, let's say here, let's say this is the position of pi over 2, the height, which means 1.57 tadi kan? 1.57. Dia tinggi sikit. Nampak tak tadi? Dia up sikit. So the position of the second point should be here. 0, 3 pi over 2. Okay? Understand? Boleh faham guys? So when we keep increase the values of T, that's why your circle tu makin naik. Makin tinggi. Because the values of T is the height. Ni. T is the height. So when you increase T, of course your graph should be higher lah. Did you understand this circular helix?
Yes.
Okay, good. What if I change the equation? Kalau saya bagi soalan macam ni, RT equals to 2 sin T, T 2 cos T. So ni bentuk apa?
Circle. Tapi pada axis Y.
Circular helix juga. Kan? Helix juga. Tapi dia parallel
Cosine
to
dekat Y.
yes, parallel to y-axis. Okay, it depends on the values of T tu dekat mana lah. Where's the position of your T. Okay. Alright, so that's it. Next, what we are going to learn. Apa lagi? Oh, question number 4. Number 3 ni simple guys. Question number 3 ni, find the vector equation and parametric equations of the line segment. So sama macam the same like chapter 1 in equations of line, we have 2 points. So in order to find the vector V, you should minus lah Q minus P. Okay, and then you get your parallel vector and then yang ni jadi you punya P naught lah. Sama je macam chapter 1. Okay, equation of line tu sama je lah. Alright. The new lesson here is question number 4. Okay, saya padam dulu. Saya nak copy benda ni. Okay, question number 4. Alah, dia tak tercopy pula. Sekejap Copy. Oh, patutlah. Dia ada lagi ni. Okay. Ni ada lagi. Sekejap, saya punya iPad ni dia sensitif sikit. So like this. Copy. Go here, paste. Alright. So question number 4. For question number 1, just plus as usual function but component wise lah. Okay, so kalau komponen I tambah dengan komponen I, J with J, K with K. Right, so for question number 1, you will have FT plus GT. Ni sama lah So equals to, for component I, you have T squared. You have T squared and T. So we will have T squared plus Ti, and then plus. For component J, we have 2T plus T squared. So 2T plus T squared J, and then plus cos T plus 5. So we have cos T plus 5K. So that's it. Okay, very simple. Next, for question number 2, we have sine. So sine multiplied by FT. So question number 2, sine multiplied by a function of FT. You have sine T here. Multiplied by function of FT is T squared, comma 2T, comma cos T. Okay, okay. Yang tadi saya buat IJK, but now I use a sharp bracket. Sama lah. Itu semua vector So we will have vector for I should be T squared sin T. And the vector for J, we have 2T sin T. And the vector for K, we have sin T cos T. That's it. Okay. Next, cross product. Sama juga guys, cross product F cross G. Macam kita buat chapter 1 hari tu. F cross G. So equals to, this is for I, J and K. Guys, my question, F cross G sama tak dengan G cross F?
Tak.
Tak sama not the same. Okay, not same because F cross G is vector. Okay, so vector ni dia ada directions. Bila dia melibatkan directions, F cross G not equals to G cross F. How about this dot product? Sama tak kalau F dot G? Is it the same as G dot F?
Sama.
Yes, the same. Okay, sama, same.
Scalar.
Because this is scalar. Okay, this is scalar. No vector. Dia tak ada IJK lah. Alright, so let us proceed. F cross G, T squared. Alah, maka camping pula. Okay, T squared and then G we have 2T cos T. 2T cos T. And then for G we have T squared 5. T squared 5. Okay. So now the same concept, close the first column. Right now we are crossing the second and third column. So 2t times 5 minus t squared times cos t. So we will get equals to, open this bracket, 2t times 5 minus t squared times cos t. So this is for I component. For j component, don't forget to put negative. So now close the second column. We are now closing the first and third column. So so t squared multiplied by 5 minus t times cos t. This is for j. Okay, and then plus untuk k pula, close the third column. So you are now closing the first and second column. So t squared times t squared minus t times 2t. This is for k direction. So we will have 10t minus t squared cos ti, and then minus 5t squared minus t cos tj, and then plus t to the power of 4 minus 2t squared k. That's it.
2t cube, doktor.
Mana 2t cube? Mana saya tertinggal
Betul lah, 2t squared.
2t squared kan? Ke saya salah ni? Ada saya salah mana-mana?
Betul.
Betul Okay. Thank you. So next kita buat dot product. Dot product ni paling senang. So question number 4. We have f dot g. Patutlah kelabu. Apa? Ft equals to apa function f tadi? T squared 2t dengan cos t kan? And then gt, we have t squared 5. Okay, t squared and 5. So f dot g should be simple, equals to t squared multiplied by t, by component ni darab dengan ni, plus, dia dah tak ada direction dah, no ijk dah. Okay, if you put ijk, then 1 mark will be deducted. So for dot product, no ijk. Okay, no direction, dia tak ada component ijk dah. Dia terus plus, dia jadi skala macam biasa je. Okay, and then next plus j multiplied by j ni, so we will have 2t multiplied by t squared, and then plus cos t multiplied by 5. So we will have t cubed plus 2t cubed plus 5 cos t. Okay guys, as I mentioned in chapter 1, saya dah pernah cakap dah, you jangan hasil darab ni jangan jadi cos t dah jadi 5t tau. Wrong. Bukan 5 ni you kena bawa ke depan ni. Okay? Kalau you buat macam ni salah ni. Ni jenayah matematik ni. You cannot do like this. Okay? 5 tu bawa ke depan. Must be take to the front. So cannot do like this. Okay? So we have 5 cos t. Dah selesai. Siap. Tak siap lagi. Boleh simplify ni. So 2t tambah t kuasa 3. 3t cube. Plus 5 cos t. Okay, done. Alright, next. Subtopic 2.2. Okay, look at 2.2. Apa kita nak baca dalam 2.2 ni? 2.2 is the derivatives and integrals of vector function. Scroll. Ni operational. Derivatives and integrals of vector functions. What does it mean by derivatives, guys?
Differentiate.
Yes, you have to differentiate. Differentiate. So dalam kuisan nanti kalau soalan tu kata find the derivatives, means you have to differentiate lah. Okay, and then guys, Actually, after this, you will encounter a lot of differentiation and integration. So if you are weak on differentiation, basic differentiation and integration, you have to do some revisions lah. Okay, because you already learn about differentiation and integration since secondary school kan. Kalau misal kata you dah lupa, okay, you have to do some revisions lah. You try Google balik, right? And if you you tak ingat lah, so you dah lupa technique of differentiation and integration, we have basic class of differentiation and integration on Friday, on this Friday. Okay, organized by what we call back to basic. Program ni nama dia back to basic. Back to basic, promosi sekejap Program back to basic ni is we will teach students on how to we will teach students about the technique of basic differentiation and integration. Basic differentiation and integration. Okay, so kalau you nak join program ni, you can WhatsApp me personally. Okay, tapi kalau you dah expert, you tak payahlah join class ni. It's just a very short class from 9 a.m. to 12 a.m. in the morning session, Friday. Okay, online class organized by Mathematics Support Center. MSC, Mathematics Support Center. So kalau you berminat, kalau you rasa you lemah on basic differentiation and integration, you nak polish balik you punya skills in differentiation and integration, you can WhatsApp me personally. Okay, I give you the link. Alright, so now get back to our lecture, derivatives of vector function. Derivatives of vector function. Okay, example. Find the derivatives of, let's say we have RT equals to 40 sine t, and then we have 5t exponent t, and then we have 6t squared. Okay, find the derivative. Derivative means you need to find what is the r prime t. You have to differentiate. Okay, so you can cari r prime t. So solution. Okay, guys, in order to find r prime t, okay, equals to what? So you need to differentiate by component wise. 40 sine t, 5t exponent t, and then 6t squared. Okay, so 40 sine t, how to differentiate 40 sine t?
Product rule.
Yes, we need to use product rule because it's a multiplication of two types of function. Okay, 40 belongs to polynomial. Okay, ni polynomial, poly, and then this one trigo. Trigo. So bila ada multiplication like this, you need to use the product rule. Okay, product rule. So product rule said, what's the formula of product rule?
UV prime plus VU prime.
Yes, UV prime plus VU prime. Okay, so now this is our U. Ini U punya V lah. Okay, so differentiating 40 sine t, we will have U equals to 40, and then differentiate sine t, we will get differentiate sine t dapat apa?
Cos t.
Yes, cos t plus sine t. So V is sine t. So sine t multiplied by U prime. Differentiate U prime. Differentiate 40, we will get
4.
4. So we will have 4t cos t plus 4 sine t. Ini baru first component. Second component, 5t exponent t.
Product rule.
Yes, again, we use the product rule. Okay? Again, product rule lagi ni UV. So U V prime plus VU prime, you all akan dapat U is 5t, so 5t multiplied by V prime. Differentiate exponent t, we will get exponent t juga lah kan? Plus, ya ke exponent t? Okay, soalan exponent t.
Betul.
Yes, exponent t, U prime should be 5. So we will have 5t exponent t plus 5 exponent t. Okay, next, differentiate this. Kena pakai product rule tak?
Tak.
Tak perlu. So you will get
12T.
12t, right? Dua tu bawa ke depan. So you will get 12t. So therefore R prime t. Okay, you nak buat dalam bentuk IJK boleh, you nak buat dalam bentuk sharp bracket boleh, it's up to you. So we have for component I, we have 4t cos t plus 4 sin t I, and then plus 5t exponent t plus 5 exponent t j, and then plus 12t.
Kata,
Ya saya.
yang J tu kalau factor tak boleh ke?
Boleh, tak ada masalah. Semua boleh. Matematik ni benda yang banyak rules kan? Boleh. Doesn't matter. Kalau you nak simplify, boleh simplify. Saya kata saja. Okay, so next. Kita nak belajar apa lagi ni? Derivative. Oh, sketch tangent vector. Okay, nanti saya akan ajar sketch tangent vector step by step. Okay, but first look here. Differentiation rules. Guys, don't worry about this. Don't bother about the formulas. What you should do is just you solve the operation in bracket first, and then baru differentiate. You tak payah dah nak hafal yang belakang ni on the left hand side. Okay, don't make yourself, don't make it complicated lah, senang cakap. You buat selesaikan dulu dalam kurungan, baru you differentiate. Ni pun sama, selesai dulu dalam kurungan, baru differentiate. Tak payahlah buat yang belakang ni, complicated kan. Benda simple je lah. Ni pun sama, selesaikan dot product, lepas tu baru differentiate. Same thing happen here and also here. Okay? Right, now kita tengok soalan sketch the tangent vector. Okay, tangent vector. So let us do the first question. Question number 1, sketch parametric curve and then draw the tangent vector. Exercise 2.2. Alah, selalu gitu. Oh, patutlah tak habis lagi. Copy. Okay, exercise 2.2. Question number 1. Okay, sketch the parametric curve. Ini bentuk apa ni guys? Parametric curve you all ni?
Circle.
Circle, yes. This is your X and this is your Y. Sama lah macam chapter 1 hari tu. Okay, the same method, same step. So X equals to 2 cos t and then Y equals to 2 sin t. So X over 2 squared plus Y over 2 squared equals to cos squared t plus sin squared t. Sama je guys, sama step macam chapter 1, the same step. So equals to 1, therefore you have this X over 2 squared plus Y over 2 squared equals to 1. So we know that this is a circle. What the radius?
2.
2. Okay, the radius is 2. Okay, next. Okay, first of all, we look here. Look at the values of t. Okay, dalam case ni, our t equals to pi over 6. Alright, so we need to substitute the values of t here, t and t. So we have, okay, rt is equals to 2 cos t and 2 sin t. So now, substitute pi over 6, 2 cos pi over 6, and then 2 sin pi over 6 is equals to, we have this. Okay, pi over 6 is 30 degrees. So 30 degrees. So square root 3 over 2. And then this one, 2 times pi over 6 should be 1 over 2. Like this. Guys, ada student tanya saya, madam, sama ke? 1 over square root 2 dengan 2 over square root, 2 over square root 2, bukan? Square root 2 over 2, sama tak?
Sama.
The answer is sama, okay? Same. Alright, the answer is same. So, doesn't matter lah you nak buat 1 over square root 2 ataupun square root 2 over 2. Sama je sebenarnya kalau you show calculator ni nota je lah. It's just the same. Okay, so we get that here. Therefore, the point we will have, ni boleh cancel. It becomes square root 3 and then here becomes 1. Okay, next we need to find the tangent vector. Tangent vector is r prime t. So bila r prime means you kena buat apa? Differentiate lah kan? So we differentiate 2 cos t. We will get
Negative 2 sin t.
yes, negative 2 sin t, and then if we differentiate 2 sin t, we will get
2 cos t.
yes, positive 2 cos t. So next we substitute with the values of t pi over 6. We will get negative 2 sin pi over 6, 2 cos pi over 6. So we will get negative 2 times square root 3 over 2. 1 over 2. And then 2 times square root 3 over 2. So we will have a negative 1 and square root 3. Okay, so let us sketch the tangent vector. Okay, previously we have a circle with radius 2, right? So we have this x and y. So kita pun buatlah macam gini. Okay, so settle. Ini 2, yang ni 2. Okay, now kita nak plot kita punya vector, position vector. Okay, this is called as position vector. Ini adalah position vector. R saja. Position vector. Okay, this is a point P. Okay, point P. Sebab kalau you tengok dalam nota buku applied calculus tu guys. Mana dah? This one. Yeah. This is position vector. Yang ni. This one. This is called as position vector. Position vector. And this is called as the tangent vector lah, of course. Warna yellow ni, kuning ni, this is called as tangent vector. And then this one, yang warna biru ni, this is the P naught. Okay? So, let us proceed with the solution here. Okay, in order to sketch the position vector, we plot from ni P naught ni. P naught ni kita plot from origin. Start from origin. Okay, coordinate 0, 0. So we have this square root 3 and 1. So start from origin, square root 3. So square root 3, you bergerak square root 3 To the right or left?
Right.
Right. Okay, sebab R pi over 6 tadi, kita dapat square root 3 and 1. Okay, so square root 3 is positive, so we move to the right, square root 3. Square root 3 ni sama dengan berapa kalau decimal? Dalam perpuluhan.
1.73.
Yes, 1.73, right? 1.73. So it should be less than 2 lah. Okay, so bila kita plot, kita gerak daripada origin, start from origin, move to the left, right side. Okay, 1.73, move to the right, and then we go up one step. Okay, so the vector is start from origin sampailah ke situ. Okay, so this is the P naught. Right, and now this is the RT. Ni RT, position vector. Anak panah yang mula-mula ni. Okay. Next, we want to plot the tangent vector. Okay, tangent vector R prime pi over 6. Kita ada tadi yang ni kan? Ni. Okay, so we have -1 and then square root 3. So, untuk lukis tangent vector ni guys, okay, nak lukis tangent vector. Kalau tadi, position vector, we start from origin. In order to sketch position tangent vector, okay, tangent vector, we start from P naught. Start from P naught. Okay, so start from P naught, kita nak gerak daripada sini, kita move ke mana ni? Right or left? To the left, yes. To the left, one step. So to the left, and then we go up or down? Up, because positive. Okay, so we goes up. Therefore, this is the tangent vector R prime T. Ni tangent vector kita lah. So this is the tangent vector. Tangent vector. Okay, that's it. That's the answer. Next, kita tengok soalan seterusnya. Scroll. How about question 2? Ni bentuk apa ni guys?
Square, circle.
Circle kan? Okay, circle dengan radius berapa ni? 4, okay. R equals to 4. Yes, also a circle. Okay, nombor 2 senang je. Okay, how about this? Question number 3.
Ellipse with major axis Y.
Yes, ellipse. Okay, so ellipse. So let's do question number 3. Okay. Jom kita buat soalan nombor 3 ni. Okay. I believe all of you already know x equals to 2 cos t and then y equals to 3 sin t. So the rectangular equation should be rectangular. Should be x over 2 squared plus y over 3 squared equals to 1, isn't it? So this is an ellipse. Major axis y. Okay. So now, okay, jom kita cari. Dia punya t sekarang ni negatif. Pi over 4. Okay, the values of t is negative pi over 4. So we have RT equals to 2 cos t, 3 sin t. So substitute the values of negative pi over 4 lah. So we have 2 times negative 2 cos negative pi over 4 and then 3 sin negative pi over 4. So we will have 2 multiplied by negative cos positive 1 over square root 2 And then 3 sine negative pi over 4 should be negative 1 over square root 2. Ini yang saya cakap tadi ni, dia sama je. Kalau you tekan calculator, you dapat square root 2 over 2 kan. Kalau you tekan calculator, you all. So dia samalah. Jangan tanya saya pula tadi, kenapa Madam jawab 1 over square root 2? Sebab ada student tanya. 1 over square root 2 ni sama Sebab kenapa saya buat macam ni? Sebab saya dah hafal daripada saya degree. Okay, kami we are mathematician, we need to memorize this. Cos pi over 4, cos pi over 3 berapa, cos pi over 6 berapa. So ini apa yang saya hafal. Kalau dia guna calculator, dia akan dapat macam ni. Sama je lah. Okay, the same. So don't worry, your answer is correct. So next we will have 2 over square root 2, negative 3 over square root 2. So next kita kena cari apa ni? R prime. Okay, tangent vector kita adalah R prime. So tangent vector, we have to differentiate our R prime t. So differentiate 2 cos t, we will get
Negative 2 sin t.
yes, negative 2 sin t, and differentiate 3 sin t, we will get
3 cos t.
yes, 3 cos t. So now substitute R prime negative pi over 4 again. So we will have negative 2 sine negative pi over 4, 3 cos negative pi over 4. So we will get negative 2 over, negative becomes positive lah. So 2 over square root 2. And then here should be negative. Jadi positif juga, 3 over square root 2. Okay, like this. Okay, so now we will have mana ni? Okay, jom kita plot kita punya ellipse pula sekarang ni. Okay, we have ellipse here. Kita nak plot kita punya tangent vector ni. So X and Y. Apa magic tadi? Y Okay, Y. So kita ada here is 3, but here is 2. Negative 3, negative 2 lah, of course. Okay. So now nak plot ni R negative pi over 4. Kita start from dari mana guys? Nak lukis ni, nak plot ni, titik ni. Titik pula. Origin. Kita nak plot vector ni. So start from origin. Yes, origin. So kita move to the right or left mula-mula? Right. Yes. Kita move to the right. Start from origin, move to the right, and then we go up or down?
Down.
Down. Okay. So we go down here. Square negative 3 over square root 2. So therefore, this is the RT. Okay. And then dekat sini ni adalah titik P naught kita lah. Next, we want to plot this vector, tangent vector. So we should start from P naught. Okay. So we have this 2 over square root 2, right or left?
Right.
Positive, right.
Right.
So we move to the right, and then we goes up. Positive juga kan? So we goes up here. So we goes up here. So therefore, this is the vector, tangent vector. Okay, so this is your R prime T. Macam gitu. Understand guys?
Understand.
Ni masuk kuis ni. Kuis saya Jumaat ni masuk kuis chapter tu. Yang buat terkejut pula. Tadi saya baru explain. Okay, so that's why saya buat kelas hari Senin supaya you all ada masa banyak untuk study. Dah belajar awal-awal dah. Okay, next this one. Question number 4. Ni bentuk apa ni gak-gak ni? X equals to T, Y equals to 1 over 2T squared.
Kuadratik.
Yes, quadratic. Thus, Y equals to 1 over 2X squared. Ni memang you all terror ni, memang at your fingertip. Kacangnya ni. Upward, downward, right or left?
Upward.
Upward. Okay.
Upward.
Yes, upward. So like this. Macam gitu. Okay. So next, apa nilai T dia? T dia equals to 1. Okay, so we need to find RT equals to T 1 over 2T squared. So R1 equals to 1 over 2 like this. Lepas tu kita ada R prime. Yes, R prime T. Differentiate T, you all dapat apa? Ni senang je. 1. Okay, lepas tu differentiate 1 over 2T squared. Dapat apa?
T.
Dapat T, yes. So substitute again R prime 1.
1 and 1.
Yes, 1 and 1. Soalan ni senang lah. So start from origin kan. Daripada origin, we plot, we move to the right, one step untuk yang ni. This one. One step to the right and then we goes up. Half step. So we get this. Alamak, saya terlebih kejap We go here. Okay, so dia mesti berada pada curve Kalau P0 tu dia mesti berada pada curve. This is P0 and this is the vector lah, of course. This is vector RT. Okay, so from P0 kita nak move to the right or left based on this.
Right.
Right. Okay, right and then up one step. So we get this. Okay, so this is the vector, tangent vector R prime T. Okay, that's it. Next kita nak belajar apa? Integration. Yes, integration. Let's say we do question number 11B. Copy. Okay, integration of vector function. Tadi derivative kan? Now integration. Again, we will do it by component wise. Component I, J dengan K. So integration dia akan jadi equals to integration from 0 until tak payah balik So integrate sine to t. What happened? So we will get what? Integrate sine dapat negative sine. Negative cos dia positive cos. Yes, negative cos. So negative cos 2t over 2, right?
Betul.
Okay, so dalam case ni, you are given the limit. So when you have the limit, no need for you to plus c. Okay, tak perlu tambah c sebab dia ada limit. So what you should do now is we need to substitute 0 and pi over 4. This is for I component. And then untuk J pula, kita nak integrate cos 2t. Integrate cos 2t dapat apa?
Sin 2t over 2.
Okay, sin 2t over 2, positive kan? So over 2, substitute 0 and pi over 4 again. This is for J component. And then next, integrate 2t dapat apa?
T squared.
Yes, t squared. So substitute pi over 4 and 0. This is for K component. So we will have negative 1 over 2 cos 2 times pi over 4 minus negative 1 over 2 cos 0. This is untuk I component. tambah untuk J component 1/2 sin 2 times pi over 4 minus 1/2 sin 0. This is for J. And then plus untuk K kita ada pi squared over 16 lah. 4 squared 16 kan. Minus 0. Macam ni. Okay, so now 2 pi over 4 should be pi over 2. So this is 0. Cos pi over 2 is 0. Cos 0 is 1. Okay. Sin pi over 2 should be 1. Sin 0 is 0. So we will get negative 0. Negative becomes positive. So 1/2i. And then plus 1/2j. And then we have plus pi squared over 16k. Alright, that's it. Okay, that's the answer for this question. Okay, next. Yang question number 10 tu simple lah . So kalau untuk question number 10 ni, since we don't have the limit, so what you should do, you have to plus C lah. Ini pun sama plus C . Alright, so now question number 12, initial value problem. You are given the condition here. And also this condition. Okay, so question number A, B tu tak mencabar sangat. Kita buat question number 12C. So kita ambil question 12C ni. Okay. Alright. Okay guys, this question asks you to find, actually this question, you need to find what is RT. Okay, so now first of all, we have R double prime. So R double prime, you need to find R prime from R double prime. So R prime T, we need to integrate R double prime T dt. Okay, so we have to integrate. Saya akan buat dalam bentuk sharp bracket lah . So cos T and then negative sin T. Like this. Okay, so we will have integration of cos. Kita dapat apa? Integrate cos. Positive or negative sign? Positive sign, alright? So positive sign T. Okay, now guys, okay, what happened? Since there are no limit, dia tak ada limit pun kat sini dengan kat sini ni, then we need to plus C. So we will have positive sin T plus C1. Ini untuk I, komponen I. Okay? And then plus untuk komponen J. Sekarang ni nak integrate sin, negative sin T pula. Integrate negative sin T, we will get
Cos.
yes, positive cos T. Good. Cos T plus C2J. Alright, so settled. Now this is our R prime T lah. Ni R prime T kita. Sin T plus C1 and then plus cos T plus C2. Okay, right now we need to find what are the values of C1 dengan C2. Okay, so in order to find the C1 and C2, we need to use the given condition. Okay, here the given condition for R prime 0 equals to negative 1. So in this case, we need to substitute T equals to 0 in our R prime kat sini. Okay, so kita kena gantikan R prime T tu dengan 0. So we will have sin 0 plus C1i plus cos 0 plus C2j. Macam tu. Okay, so again sin 0 is 0, cos 0 is 1. So we will have R prime 0 equals to C1i plus 1 plus C2j. Okay, now what you should do is you have to compare. Compare with the given R prime 0. Okay, dia bagi R prime 0 equals to negative I. Negative I. So you kena compare antara dua ni guys. R prime 0 ni yang kita dapat. Okay, this one yang kita dapat ni. R prime 0 dengan R prime 0 yang ni. Okay, so you can compare by component lah. You have to compare I with I, J with J. So in this case, if we compare I with I, thus we can get C1 equals to negative I. So negative 1.
1.
And then if we compare J, kat sini ada J tak?
Tak ada.
No J, right? So 1 plus C2 equals to 0J. So what happens? C2 becomes negative 1. Thus, we need to substitute into the R prime T yang kita dapat mula-mula tadi. Dalam ni, we need to substitute here. Okay? Sebab C1 dengan C2 tu kan. So kita kena substitute, then we will get sin T plus C1. C1 is negative 1. So minus 1I. And then plus cos T minus 1J. Like this. Okay. So this is R prime T. Tak siap lagi? Tak habis lagi. Sebab soalan nak RT. Yes, you have to integrate again. So RT is equals to integration of R prime T dt. So you kena integrate yang ke atas ni. Integrate function ni pula lagi sekali. Okay, so we have to integrate. Saya buat sharp bracket lah So sin T minus 1 and then cos T minus 1 like this dt. So integrate sin T, we will get negative sin of cos. Negative cos T, yes, good. So negative cos T. How about negative 1? Integrate dapat apa? Yes, negative T. So minus T. And then plus, remember we don't have any C here, any limit right there. So we need to plus C1 I. Okay, and then plus integrate cos dapat apa?
Sin T.
Sin T. And then how about this?
Negative T.
Yes, minus T plus C2J. Okay, so we will repeat the same step. Alright, so dapatlah RT. Ni RT kita lah. RT kita yang atas ni. So let's say saya salin balik. Negative T plus C1I plus sin T minus T plus C2J. Okay. So next, kita nak cari C1 dengan C2. Okay, our objective is to find C1 and C2. So we look at the given initial condition here. Okay, we have R0 equals to I plus 2J. Again, T equals to 0. Guys, kalau the question gives you R pi over 2, so you should substitute T as pi over 2. It depends on the given conditions lah. Not necessarily always 0. Okay, so in this case, again, T equals to 0. So we just substitute 0. So R prime 0, we have negative cos 0 minus 0 plus C1I plus sin 0 minus 0 plus C2J. Okay, so cos 0 is 1, sin 0 is 0. So we will have negative 1 plus C1I plus C2J. Okay, so we need to compare with the given condition. You have R0 equals to apa tadi kat atas tu?
Negative 1.
I plus 2J kan? I plus 2J. So I plus 2J. Alright, so jom kita compare. Ni. I dengan I. So negative 1 plus C1 equals to 1. Therefore, C1 equals to 2. And then komponen J, kita ada C2 dengan 2. So yes, C2 equals to 2. Okay, therefore substitute into RT. RT equals to negative cos T minus T plus 2I. And then plus sin T minus T, sin T minus T plus 2 plus 2J. So that's it. That's the answer. Okay. Understand, guys?
Understand.
Okay, good.